Now we're live on YouTube. Over to you, ma'am.
Yeah. Request all of you to stay muted.
Yeah, good afternoon, everybody. And welcome all to the afternoon session of Curry Leaf Day 1. We have an invited talk in this session to begin with. And it's my great pleasure to introduce the chair for this session, Garima Gogia. So Garima completed her studies from Delhi University, and after a brief stint as a faculty there, she has moved to Azim Premji University in the School of Mathematical Education. So yeah, Garima.
Yeah, thanks, Kiran. Yeah, it's my pleasure to welcome our speaker for the second lecture, that is Dr. Rakhi Banerjee. Dr. Rakhi is currently an associate professor in the School of Education at Azim Premji University, Bangalore. She has taught at various levels of education, school, undergraduate programs, and postgraduate programs. Prior to joining Azim Premji University, she has held faculty positions at Tata Institute of Social Sciences, Mumbai, and Ambedkar University, Delhi. She has been developing and teaching courses in child development, teacher professional development, cognition and learning, and mathematical education. Her doctoral work carried out at the Homi Bhabha Center for Science Education, Mumbai, was on developing a teaching learning sequence for grade 6 students to help them understand beginning algebra based on their prior understanding of arithmetic. Subsequently, her work has focused on looking at curriculum, textbooks, and their transaction in the classroom, highlighting students and teachers' role in the process. Her focus has always been on how can students make sense of a subject as abstract as math. Today, she is going to talk about the teaching and learning of maths through insights from algebra. So without taking much time, I would like to invite Dr. Rakhi to take over.
Thank you, Garima, and I thank Karili for inviting me. So I'm not a mathematician. I do have a training in mathematics, but since then I have moved to doing something called the math education. And as I think Garima just said, that I'm interested in seeing how students can make sense of mathematics rather than do a lot of very complex mathematics, which they may themselves not perhaps appreciate or understand. I'm going to go back to some of my work during the doctoral time, as well as much of the work that I've done after that. And I'm not going to necessarily do a very academic talk by citing papers or citing or giving appropriate references, because I want it to be more free-flowing at this point. And I'm going to make maybe very large claims from very small data at this point. But please bear with me, and I would be happy to take questions after that. Is my slide visible?
Yes.
Okay, great. Okay. So I'm going to go back to some of my work during the doctoral time to actually ask much larger and more fundamental questions. But I'm going to use data from that work as well as from my more recent work. And I felt that it was useful because it's a very short time. It's useful for me to focus on some particular idea to talk about my larger concerns, actually. And I start by focusing on the content area of algebra, which actually is something very fundamental, not just for high school and higher secondary, but also for all those who study mathematics later on. So what is algebra? Of course, we have learned algebra in school by basically 2-3 kinds of things, that you have to simplify expressions, you have to find values of x or 2 variables in simultaneous linear equations, and we have done a little bit of substitution. But however, I think many of us who like mathematics or have been participating and engaging with mathematics for a very long time, we realize that algebra, that is only one skill aspect of algebra, but there is not something much more substantive. And what is substantive is that it is basically what is algebra is symbolizing generalizations and structures. And these structures at this point, because I'm going to talk about middle school, at the middle school levels, I'm going to use this structure word to denote structures as are visible in polynomial expressions and maybe equations and things of that kind. Then algebra is also a language for expressing generality. It actually allows us to manipulate and reason about generality, not just to express, but also we reason about the generality. Probably I'll give you some small snippets into these aspects. Algebra is also about solving equations. It's about problem solving with appropriate formulae, expressions, and so on. And last but not the least, it is about functions and how we can think about formulating formulas, table, and graphs. So that's what is algebra in the much larger sense, beyond saying that algebra is about expressions where we manipulate expressions. Of course, that's a very significant part. I'm going to talk about that too. But why actually one should worry about algebra? Because we often make a claim for learning mathematics by saying that it is useful in the day-to-day life. And the moment algebra arrives in grade 6 for the child says, this is not related to my day-to-day life. So why should I worry about these XYZ? I'm happy to write XYZ in my language and social sciences and sciences, but I don't think there is any scope for such letters in mathematics because their experience of mathematics is very different in the primary grades. But we know that algebra provides a gateway to higher education in maths and all allied disciplines. It's often entry to prestigious courses and professional courses. It actually provides you an access to liberation or emancipation, as I call it, and many others actually call it. If this is not felt, then it alienates students and leading to very early dropout from mathematics. So students really want to leave mathematics they make up their mind by grade 8 that this is not what I'm going to do ever after this. So they wait for 10th and wade through it. So, but if we add depth and coherence, then algebra is extremely powerful. And I'm going to show this power only in very, very limited ways. But even then I would try and do that. So I'm going to highlight the symbolic aspect of algebra, even when I want to situate algebra in some very meaningful context today. So symbolism is actually what makes algebra distinct from fractions, rational numbers, arithmetic computations that students learn in the primary grades. And it brings an unprecedented unambiguity and precision in their writing. That's the expectation. Whether that happens or not is a very different question. We will talk about that. But it is exactly these symbols which I think throws students off guard. And years of their work with computations, it suddenly seems it has absolutely no relevance for these students. And these are some snippets from grade 7 students. Do you see this slide and do you see what students are doing? So they have been asked to simplify an expression, which is actually with numbers, despite that. So numbers is a familiar terrain, but despite that, the moment that so many operations and so many numbers come up, students do what they have done. And you see, it's very strange that this child actually thinks that the 21s can be taken apart from the 19s and the 5s and the 4s, which were basically the multipliers. And now you see this. This is an algebraic expression, not of the same child, but the same grade. And this child is solving this algebraic expression by, to begin with, it is okay, because teachers often tell that collect like terms. They don't utter the word that was important in the numerical context, which is distributive property. You don't say this here. And all that we say in classrooms is collect the like terms. Then children dutifully collect the like terms and the unlike terms. And then once they have simplified that much, then there is a conflict. Now, what do I do with 8x plus 2y minus 13? So the child is tempted to say it is 10x minus 13. And finally say something like 7980. It's 13x. Because this gives you a lot of satisfaction that I have arrived at some number. Because number is what I need to arrive at. And then you see this, which is in the context of an equation. Again, a grade 7 child. And you see such meaningless use of symbols. It's actually very, very striking and remarkable that how children find all of this absolutely meaningless. Equal to signs are placed all over the place. Anything is cancelled by anything. You can just divide by anything. You can subtract any number. And you find something which you feel is the penultimate step of the solution. So this is what I call the symbol, basically symbol gap, symbol sense, or lack of it. Let's look at more symbolism. Now this is grades 8 to 10. This is not from my work, but some other work that has been done way back and continues to be done. David is 10 centimeter taller than Con. Con's height is 8 centimeter. What is David's? And you see all these different responses. 10H, H10, D, DH, H equal to H plus 10. Can we unmute and talk maybe a couple of minutes about some response which we seem to feel that I know why the child has written so? Is that a possible?
You can raise hand and I can...
Yeah, unmute them, yes. So can we spend just a couple of minutes thinking about why children actually think this?
Can we just raise hands? Yes, Praveen?
Yeah, H is equal to H plus 10 because the child would have thought that David's height is H and Con's height is H and David's height is 10 centimeter taller than Con's height. So he added H plus 10 and given H equal to H plus
10. Right. But this also seems very similar to something else, which is perhaps a computer programming where you keep renaming and relabeling. So you also see there is an intrusion.
Yeah.
Any thought about why the child would have written 10H or H10?
Can we have some hand raises if possible? Okay.
Yeah, go ahead, please.
Anirudh?
Yeah, somebody has heard 8 instead of H. That's why they're writing 18.
Okay. So you're talking about 18, right? So somebody has heard 8 as instead of H. Okay. Can there be some other reasoning?
Mugdha?
Yes, Mugdha.
Maybe for that student, 10H may stand for 10 plus H.
Correct. Yes. So 10H is 10 plus H because that's how probably Roman numerals are also written. And many, many things are written. 1.5 is written like that when it was 1 plus half. So why not write 10H? Yes, Varsha?
Yeah, actually, whatever you mentioned about 1.5, that's what even I thought for H10.
Yes.
Because they just add it along with H.
Yes.
But 18 is actually more than poor listening. 18, if you see, if you add 10 letters from H, it reaches the 18th. Or let's say H is 8 and therefore 10 more is 18, which is also something which we promote in all our lot of puzzles that children do. It promotes this kind of understanding. So algebra has these intrusions from many different places. Okay, so let's go ahead. So now let's see this. So this is again from a grade 7 class.
a teacher trying to explain something, and she says 5 pencils plus 6 pencils is 11 pencils. Therefore, 5p plus 6p is 11p. And then she asks, what about 8p plus 5r? In her mind, it was 8 pencils 5 plus 5 rubbers is equal to what? And then children's spat comes the reply. It is 13pr, which is 13 pencils and erasers. Or the children tell the teacher, let's call it 13 stationery. Do you see how the letters are being used? Does this make sense? We are trying to make these algebraic symbols or letters in algebra accessible to children by using certain kinds of analogy. And we see that this analogy is not correct. We'll come back to this later, perhaps again. Sorry. So we see some more examples of something that I showed you as 3 examples of children's work. Now, in this grade 4 class, a teacher is trying to teach children multiplication of a fraction by a whole number. And she says that there is no problem with this. You just have to cancel numbers. And she shows that, and how do you cancel? You cancel a number in the numerator with a number in the denominator. And she says that 2 and 7 are co-prime basically. So therefore 2 and 14 is something that we should cancel. 7 and 14 is something that we should cancel. And the teacher cancels the 7 and the 14, and she writes 2 by 1 into 2. And a child gets up and says, I'm not understanding, why can't we cancel the 2's in the numerator? Why should we only cancel the 2's in the numerator and the denominator? And then you see this in grade 8. In grade 8, the teacher is trying to help children solve some actually an algebraic identity with a complex sort of expression, including a square root. And then she makes the translation to root 3x whole square, saying that this is in the form of ab whole square, which is a squared b squared. And then she says that the square is applicable for root 3 and x. She simplifies it, saying that square root and square gets cancelled. So this word cancel for all symbolic manipulation is something worth noting. And then shows by saying that root 3 is t to the power of half, which when done a whole square, the 2 and the 2 cancels. The 2 in the half and whole square, those two cancel. And then again comes the square question. Should we not cancel the root 3 and 4 root 3x? Do you see how children are grappling with something like this? Okay, let's go ahead. I mean, if you want, I will stop at any point of time. I'm happy to wait and think about. So, so symbolic expressions and symbolism being reduced to levels of cancellations. Sometimes these cancellations are of -2 plus 2. Sometimes these cancellations are of 7 and 14. Sometimes these cancellations are about a square root and a whole square. So all things cancel in mathematics. So all you remember in mathematics or in algebra is that things have to be cancelled. So, and then this is complicated by the symbolism that we just spoke about earlier, a little while back, that 20 plus 3 is 23, 2 plus 1/4 is 2 1/4. But A into B, we have decided to write it as AB. And A plus B is not AB. Yeah. So while here the operations are always addition, in this case, the multiplication is written like this. Similarly, in the other context, 43 plus 28 is 61. Children know how to do this. But then we give them this question, 2y plus 3. And children are prompted to write it as 5y and not as 2y plus 3. Now, there is a conceptual issue here, which is not just a matter of forgetting, remembering, or anything. The fact is that at this level, it has to be these expressions, these small polynomial expressions have to be dealt with multiple meanings. There is a process aspect to it, What is 2y plus 3? That you multiply a number by 2 and add 3 to it. And there is a more relational aspect to it, which is 3 more than twice a number. And the moment we speak of this relationship, it starts to reveal a broader algebraic structural relationship rather than just a sequence of steps. Sequence of steps, as we would realize, are actually of very little relevance the moment students reach a point when they're looking at sets, functions, relations, and so on and so forth. What we realize, therefore, in algebra is that the familiar symbols like plus, minus, equal to take on multiple meanings. They're just not one meaning. So now, what is the equal to thing? Now, equal to actually is something which, truly speaking, helps us record and reveal structure. But in children's writing, at least in the primary grades and actually much in the later middle school grades also, we see that twice 6 plus 2 is basically written as 2 into 6, which is equal to 12, which is not equal to, which is 12 plus 2, which is equal to 14, in complete violation of an understanding of what this symbol equal to means. And for many of our students who come to study math education, adults, all adults, they too actually for the first time think that why did we always put this equal to sign there? Similarly, children will say that 8 equal to 5 plus 3 is not a correct statement. The correct statement is 5 plus 3 is equal to dash, which is the dash to be filled by 8. Okay. Similarly, so this equal to has multiple kinds of ramifications. So 23 minus 3 plus 9. How should you solve it? Should you solve it as 20 plus 9 and 23 minus 12? What guides this? So the fact is that of course, there are some conventions of solving these expressions with multiple operations, but beyond the conventions also, and the conventions are guided by the structure of the expression, but it is also about then having accepted to certain conventions so that there are precise values, unique values of expressions. We need to understand that equal to once again means that they have equal values and not anything else. So once again to ask, is the expression 685 minus 492 plus 947 equal to the one on the right hand side? So can we talk about this without computation? Can we again raise a hand or two and say whether these are equal or not equal? And how have we come to know that these are equal or not equal? Are these two expressions equal? How do we know? Yes, Sanchita.
Ma'am, in the last line, if we get cancel 947, then 685 minus 492 equal to 492 minus 685. So there will be minus thing and.
Okay. So this is a very typical mathematical statement. The fact that once you have taken out the equals out, then the other part should be equal. But in this case, these are not equal because subtraction is not commutative, right? But for children, they will see whether the three numbers are the same and whether the two operations are the same. They don't necessarily see that 685 minus 492 is not the same as 492 minus 685. Teachers, of course, tell them a lot that you should not do this. You shouldn't, this is not commutative. This is integers, but it has varying degree of success on children. So equality is basically about equivalence. What conditions, under what conditions are two expressions equivalent or equal in value? Our understanding is that equality is about equivalence in value of expressions. And that's what perhaps we need to utilize a lot more in algebra. Similarly, if you look at this expression now, if you look at this expression now, can we now say whether these two are equal or not? 23 plus 56 into 89 minus 74 is the same as 56 plus 23 into 89 minus 74. Are these two equal? Yes, Anjita.
Ma'am, the same thing. We can cancel 74 both sides, and then I can write like 56 cross 89 is not equal 23 cross 89, so they are not equal.
Correct. So once again, you're harping on the structure of the expression, but it is this structure of the expression which is neither clear to children, and therefore there is no justification on the basis of equality or equivalence and structural relationships that is available to children. So these are some snippets from the intervention that I tried with students of grade 6, and where we were trying to connect structure of the expression to their values and equivalence. Yes, Kiran?
Yeah. Ma'am, just a quick question. So what is the best possible way to introduce the sign equality?
The sign equality, I'll share some snippets of that. Okay. Yeah. So, but I will not do all of it, but we'll talk about it a little later.
Sorry, because I faced this problem when taking a class. So they really couldn't understand when I wrote like 1 is identified with the rational number 1 by 1. And so they got confused what is the difference between equality and identification.
Correct. Yeah.
Okay.
So you will see lots of examples here. So one is this. This is a computational example of equivalence. Why is 13 plus 2 into 8 equal to 29? Because the structure of the expression, which is a term 13 and term 2 into 8, makes it mandatory that it is the way it is. Similarly, when we have an expression of this kind, 19 minus 4 plus 6, once again, the structure dictates that the solution, of course, can be done in any order, because now you realize that once we have identified these structural components of terms, then it is basically all addition and therefore commutative entirely. And one can do it in any way. So one looks at it like this, and there will be children who would do 19 minus 4 plus, and there will be children who will do minus 4 plus 6 first. And in all cases, the answer will come out to be the same, which once again is a sense of equivalence or an equality, that each of these are equal or equivalent because of commutativity. Then you see something like this, which is more complex, which uses distributive property. And children once again identify which is a common factor and which terms can be combined by using distributive property. And they apply distributive property multiple times to come to a solution. While you see a more eccentric solution here, where children, expression is simply an addition subtraction expression, and the child decides to find the smallest differences so that the answer is whatever it is. So at every point of time, we spoke to children about why you think that different methods got the same answer. And because these are terms, because this is all addition, because they can be rearranged in any way, it is this reasoning, structural reasoning, that we try to incorporate and thereby think about what is the value of an expression. The fact that all numerical expressions will have identical values, precisely because we can follow only certain kinds of transformations are valid, and these transformations are guided by the properties of commutativity, associativity, and distributivity. And then you see this. So we did a lot of work with arithmetic to make it available that in algebra also, since the x is any letter, the letter is any number, therefore we don't worry about what number it is. But as long as it is the same number, you can apply exactly the same properties as we use for numbers. And that's why you see the similarity or sameness of these responses with this response. They do exactly the same thing. Or sometimes, in order to make some more sense, there were children who actually wrote 8n as n written 8 times, added 8 times, and then saying that it is 9 times n, which also was perfectly fine. So we did one round of generalization from arithmetic. We did a lot of work on equality, equivalence, and computations, so that the properties and the understanding of structure derived in arithmetic could be applied to algebra. In that way, this is one level of generalization. But so this is another thing that we did a lot. Actually, this is actually a very sophisticated thing that we did, but we did something much more primitive to begin with, which I didn't include today because we don't have so much time. So we consolidated this idea of equivalence in many ways. One is to do this. We gave them an expression and asked students to write as many expressions as possible, which they think is equal in value to this, but they are never allowed to compute the value. It's not that you find the value of this expression and find more expressions. What can you do to this expression in such a way that the value remains same? And you see that children try to put brackets, children try to rearrange the terms, children try to decompose certain terms and use brackets. Of course, children do make mistakes. So the asterisk ones are all small errors. So they try to do a compensation. So this compensation worked perfectly well with addition, but they had problems when it was a subtraction. So they increased one number and decreased the other number. In addition, it works, but in subtraction, it doesn't work in the same way. So once again, a detachment between the action and the interpretation of the symbol itself. Then we asked them to do for this. So write as many expressions as possible, which you think will be equal in value to this. And it is in these ways that we nurtured their understanding of, growing understanding of equivalence. And this also helped us understand how structurally expressions are constrained or freed up, whichever way. And then we did for algebra. We gave a similar expression for algebra, told them to write all algebraic expressions which the thing will have the same value as this. So constructing and deconstructing symbols, basically. We played a lot with symbols in these ways and in many other small ways, actually. Then we thought that this is not enough because you can't only work with the realm of symbols. We should think about this, but I'm actually not giving the examples from the study itself, but I gave some generic examples. So patterns and generalization, count the number of tiles and the number of corners and see, and can algebra help you decipher a rule for it? How many matchsticks are needed for such a large square? In fact, this provides Garima has been sitting through my classes, so this takes a lot of time, even for adults. This square pattern is not easy to discover, to actually decipher how many matchsticks are there. There are multiple complications, but you can always reduce it. You can make it smaller. So you don't necessarily need to start with something as complex as this. Okay, so this is something that we did, and we had a lot of fun because for every pattern, children came out with 5-6 different expressions. And then the question was that these all look different. Do they represent the same expression, same pattern, or a different pattern? And how do we know that? How do we justify that the expression that we've written actually really represents the pattern? So it leads to huge amount of interesting conversations in the classroom. Then calendar patterns was something that we did, and I will show you some snippets of that. So give a calendar, tell them to write some patterns as they find useful. This is not necessarily the same calendar that was used here, but you see that how children are trying to find small bits and pieces of it. That there is a 1 and there is a 7 and 9. When this number becomes 4 here, this becomes 10 and 12. And then they start writing G plus 6, G plus 8, G minus 6, G. And they're trying to see, if I place the G somewhere else, how are the other two numbers going to change in representation? These are actually about children now owning the expressions that they're writing. Instead of I giving as a teacher the expressions that you simplify this expression, you substitute the values, but they're doing both things together now. You see that children made cross here and they try to see what is the representation here. They actually try, so now I'll show you something else. So they also tried to write actually very, very simple things. 1 is followed by 2, 7 is followed by 8, 14 is followed by 15, 2 and 8 in the diagonal, 3 and 9, and then they start writing R and R plus 6. If this is R, then this is R minus 6. So you see, they start seeing the reverse relationship. This is 6 more. So if you put this as R, then this is 6 more. If you put this as R, then this is 6 less. And these are the opportunities that children actually need to make sense of these symbols and not just told to simplify expressions. Then they started writing, what is a pattern that I can see? If I add in this particular kind of shape, which is a whatever, some kind of 3 by 3 with some missing items. And then you see that if you add the corner ones, the sum remains the same. And it is not just same, it is twice the middle number. And they try to prove that. So simple, small sort of steps towards owning some bit of algebra. And then some games and puzzles. If we have time, we will play a little bit. Okay. I have just put the question right now. I'll come back to this. And then there are lots of games. I mean, these are just 2 games. I'm quite sure most of you, since you're all so fond of mathematics, you will know lot more games to play with. But these are some 2 games. One is a NIM game and one is a mind reader, which also you may be aware of. But I'll conclude this and go back to that. So what is to teach and learn mathematics according to me? So my question, I have some fundamental questions. Should we teach rules and procedures and learn by practicing them? Should we help students construct these rules and procedures and more connections and relationships? What might actually construction mean? Sitting alone and struggling with interesting problems, co-constructing and sharing with peers. Should we talk about our mathematical ideas? Should we use a lot of language in classroom? Mathematics has been a subject where there has been very little language in classroom. How do we make sense of symbols and operations on the symbols? Actually, what is a symbol? What kinds of symbols do we use and how do we operate? What context might promote symbol sense? Which basically means when to use symbols, which symbols, how to work on those symbols to draw inferences. And I end here. But if you're interested, we could play this game. I am taking a game which is not the original one. Can you see my slide? Can you see the web page?
No, Rakhi, we see the slide.
Okay, should I stop share and share again? Okay, so have you seen this? Are you all aware of this? Okay.
No,
So this, sorry?
Yeah, I'm not aware.
You're not aware. Okay, so this is Andy Norton in 1963, I think, made this game. This is a more recent version. It's very kiddish, but the original version requires flash player, which we don't have on our machines anymore. And this is an equivalent version of that. So think of a 2-digit number. Can you see the entire screen?
Yes.
Yes. Okay. Think of a 2-digit number from, so you can see all these numbers here. So it's 8, 9 till 82 is there actually. Add the 2 digits of your number together. Once you have added, subtract, add the digits, actually add the 2 digits and subtract this sum from the original number. Is the question clear? So think of a 2-digit number from this table. You add the digits and take out that sum from the original number. When you have found that answer, identify the answer in this table and stare at it. Are we ready?
Yes, I suppose.
Okay. Is that correct?
It's correct for me.
Is it correct for everybody? Can we just raise hands?
Yes. Yes, correct for me also.
Oh.
Yes, yes.
Okay. So of course, I won't belabor this. I think you would have all figured out by now why
But
this is so.
how is it possible?
So do you want to try again?
Yeah, surely.
Okay.
We will love to try. But how it works?
So please, here is the table again. Once again, take a 2-digit number, add the 2 digits subtracted from the original number, subtract the sum from the original number, stare at the symbol. Are we ready?
Yes, we are ready.
Amazing.
Okay, I'm going to stop share. I'm quite sure it's not. It's very simple.
So now the main question is, what is the pattern?
What is the pattern? What is the pattern? In fact, this one is a little crooked. It starts with 8 and ends at 82. The original Andy Norton one starts at 1 and ends at 99. So it basically does all of it. So very interesting questions actually are there. It's very simple, but children have a lot of fun. In fact, my daughter, when she was in grade 5, she didn't know algebra, but she worked out systematically with all the numbers and found what could be the possible answers, why that symbol, where are the symbols repeating. So it's lovely to explore that. Similarly, there is a NIM game. NIM game, do you know? Most of you may be aware of, right? Garima has been playing that lot recently. Okay. Okay. So NIM game is also something.
Maybe you can tell we have
some time.
Yes, we have time. A brief idea might be good.
Okay. So you can see this?
Yes.
So at this point of time, there's a target 23 and two players play one after the other. You can add numbers 1, 2, 3, or 4. The first to hit the target is the one who wins. So what do you want to start with? So in this particular case, at this point, I'm playing with the computer, but you could tell me what number should I start with?
3.
Okay. So now the computer played and we have reached 4. Now what is the next?
Yeah, participants.
What is the next number I should?
1.
Okay. So it got you to 8. Now?
So you can add any number from 1, 2, 3, or 4.
Two.
Okay. So it took you to 13.
4.
No matter what you do now, you will lose. Means I will lose.
Yeah.
So the question then is, what's happening? What should you do? And how does it vary with the target number and the numbers that you can take out? So what is a winning strategy? Can you, if you see the number and the bucket that can be taken out, then can you tell whether you will win or lose? Right, correct. So somebody has come up with the same thing, so if we mark every number which is a multiple of 9 by same card, that's the answer every time. So then there are interesting questions. Why only 9? Then which numbers? Sorry, Sanchita?
Ma'am, multiple of 9 or multiple of 3? I think multiple of 3 then.
One should explore. Whether it should be a multiple of 9 or should it be a multiple of 3? What difference does it make? What numbers are possible answers? Correct. So 9x. Junaid Saab ne keh diya. So this is what algebra does. But for children, this is the last thing they will take recourse to. They will actually take examples. So as most of you are mathematicians or budding mathematicians, you would know how powerful taking examples are. And it is examples that children actually take, and we take them out saying that this is not the mathematical method. The mathematical method is one of using algebraic symbols, geometrical symbols, and proving it. But then that we take away their way of reasoning. And if we take away their way of reasoning, then children lose it completely. It's like Shakespeare wrote a play and East wrote poetry, and you have to remember and revise and regurgitate, but we have no capacity to write a statement. That's not how mathematics would work. If language does not work that way, then mathematics also cannot work that way. Sciences, of course, does not work that way. So that's the only claim that I am sort of making. I hope I have communicated something which is of interest to others.
Sure, ma'am. It was interesting. Ellen.
Yes, Ellen.
So this is very interesting. You touched upon various things that the teacher faces in a classroom. When we try to give analogies, places where we fail in communicating mathematics to people who are in the beginning stages.
Right.
Are there what are the remedies? Like, you have talked about different problems. I understand they're not simple. I'm not expecting a collective answer, but what work are you doing on, or where do we look for different ideas which we can implement? We can try and implement.
So I did it for algebra. I sort of try to give a small solution to it. Highlight the structure for children, not when children are doing algebra, but when children are doing arithmetic. And integrate that structural sense with looking at structure in generalizations, in patterns, actually. So that's the kind of thing I'm talking about algebra. You can do something similar for, see, every small domain of school mathematics comes with its own meanings and purposes. So for fractions, there are once again a set of meanings and possibilities. And once you introduce those to children, they start reasoning with something as weird as 2 by 3 and half by 2. So you have to do it content by content in my head, actually. But there are these larger questions that what are symbols? Why do we use them? When do we use them? What do we use it for? I think at the back of our heads, we have to keep that running.
And one of the core ideas that I get from your thing is, instead of trying to explain things after introducing symbols, it's more important that we introduce it when we handle numbers.
Yes.
The symbols. For example, distributivity, we just add similar terms.
Yeah.
But it's distributivity property.
Yeah. Just as we say tell children these ad hoc rules, collect like terms, collect unlike terms, collect like fractions, we can also tell them what is a genuine reason for it. If they can understand ad hoc rules, they may be probably able to more understand and appreciate genuine mathematical ideas.
Understanding ad hoc rules
is more difficult. Yes, it's much more difficult. Yes.
Okay, I think it's very interesting. I think I'll hope to connect with you at some point about education. Thank you.
Sure.
But ma'am, while school students or even up to the college, they are more accustomed to working with examples of specific cases. sometimes it becomes difficult for them to understand the abstract theory behind it. Right. So I face this problem. So I mean, then the best way to introduce this theory is to go back to their level of understanding, work out the examples, and try to extract the features. So what are the common features in all these examples? And then give the theory.
Yeah, they should be able to come up with some generalization. No? So what we call conjecturing. And conjecturing is followed by justification. And the justification, you may find while justifying that the conjecture that I have held is not true, I need to refine it. It takes much longer. But I think then the ownership of that particular piece of knowledge does not reside in the teacher, but with the student, whatever level it is.
Yeah. Thank you.
Do we have any more questions?
They finished before, much before.
I'll go with one more question, which is mostly happens with teachers, school teaching. So as you mentioned, conjecturing. So we give multiple examples, and then if you want to make the students elucidate the concept from the examples, identify pattern, and then form the concept, it takes its own time. We have to provide a time and also a space to think. Say we are creating a space where people are open to make mistakes and other things, but time is a serious concern when we at school level, because wherever I read, they talk about two things: effectiveness and also efficiency of teaching. So efficiency is also something to be taken care of. So how can that be done? This time, do you have some opinions on that?
Yes, I do have. In fact, I have very strong opinions on this. So I think grades 1 to 8, there is a lot of repetition. There's a lot of redundancy, therefore. I'm not saying get rid of the redundancy, but if you have stronger foundations, you don't spend time reminding children every time of the rules learned and forgotten from the years before. Children will be able to move faster. It takes a lot more time to establish that foundation than to speed up to the higher order processes. So you need to do a pro-con, a cost-benefit analysis, which I have not done. I mean, I work probably in more idealized spaces in my head. But I feel that it is really, really possible, because the amount of, say, in Bangalore, every unit test or a midterm and an annual examination, 3 weeks before that, the regular classes are almost not happening. Teachers keep revising. So I wonder what is the hurry to finish up the portion in a crunch time and then keep repeating exactly the same ad hoc rules in those 3 weeks. Those who did not learn it in the first 2 months will not learn it in the 3 weeks also. But grade 9 onwards, things change. And I have not given great thought to that, because you actually are encountering multiple problems there. The fact that students have very poor base, they do not know rational numbers, rational expressions, fractions, integers, and simultaneous linear equations, and you end up with quadratics now and higher orders.
These are subject things. There are also market demands that come.
There's also market demands, yes. But market demands are anyways not getting fulfilled, no? Since they can't live up to the expectations of the subject demands.
But at least from 1 to 8, the parents there is no demands from the parents. They give us the space, so we can try to push.
Parents are very demanding even then, but their demands.
But after 9, the demands escalate.
Yes. No, but I'm quite sure that if students came well prepared, at least with the fundamental ideas of some fundamental basics, rudiments on which all that will be built in grade 9, 10, I think life will be much simpler.
That's a great idea. I'll think about it, about using the time between 1 and 9. Thank you.
Do we have more questions? So if not, you see the chat also. So there are thanks and some appreciation in the chat.
Thank you so much.
Yeah. So it was wonderful having you, Rakhi, here. Though
Thank you.
Most of us are from undergraduate, we still relate with the kind of non-coherent and that redefining of definitions at various levels as per the convenience. We do struggle with that as well.
Yes.
And the idea of owning the ideas, the definitions, and reflecting upon them, we all suffer from that problems at this level as well. So we would like to, okay, there's a message in the chat. Is pressure good for a student? So this is Sasha.
Some amount of pressure is good, so that children don't become complacent. See, we learn, I think all of us have learned when we have been pushed and challenged a little bit. If there is nothing to learn in that, or there is no challenge, then perhaps our intensity to learn it also decreases. So I think there must be some level of anxiety, tension, stress to support learning.
Yeah, I hope Sashadhar Datta got answers for his question. So on behalf of the entire Curryleaf team, I would like to thank you for this wonderful lecture today.
Thank you so much. Thank you, Garima. Thank you, Kiran. Thank you, Curryleaf team.
Welcome. I must tell you, Professor, we are not accustomed to such interactive talks. Because, right, it's mathematics. So,
I know.
So this talk would have come as a sudden shock to many of our participants.
I know.
Yeah. But I really hope that we'll continue your association with MTTS.
Sure. Thank you so much. Thank you.
Thank you, ma'am. Okay.
Bye-bye.
So with this, we'll end the talk by Professor Rakhi Banerjee ends, and we will move to the workshop on LaTeX. I request the workshop team to take over.
Thank you very much.
For some time, Kiran?
Yeah. It's up to you guys. We'll wait for some time and proceed. Yeah.
I will take a leave. Thank you so much.
Thank you, ma'am.
Thank you.
Okay, so we'll start in 3 minutes. Yeah. Okay, so hello everyone. Good afternoon. So this is a final event of the first day of Study Day 2022 that we are celebrating, and we are going to have a workshop on creating presentations using LaTeX. And the speaker today we have is Kiran P. So as most of you know, Karili is a math club of MTTS alumni, and one of the aims of Karili is to bring together the participants of MTTS and also organize some events that are targeted for wider mathematical community. So ranging from undergraduate level students even to PhD level, and just now we had a talk by Professor Banerjee, which might be of interest to many teachers, which covers different pedagogical aspects as well. So yeah, let me now just introduce the speaker that we have for the LaTeX workshop. So we have Kiran P. He is a PhD student at the Department of Physics at IIT Dharwad. Kiran has completed his MSc from University of Mysore in Physics. Currently, he is a research scholar working in the area of physics, more specifically quantum information theory. And recently, he has conducted a workshop at his institute on LaTeX, targeted for the students of his institute. He is very well versed with different features of LaTeX and programming. So I hope everybody is going to have a very nice session, very nice 1.5 hours, the upcoming 1.5 hours. So before inviting Kiran, let me just say a few instructions. So participants, feel free to unmute yourself and ask your doubts in the session. The more you interact, the more it is effective. The more effective it is going to be. And for the participants on YouTube, they can post their messages in the chat, and either during the session or towards the end, we will convey them to Kiran. So yeah, without any further delay, I invite Mr. Kiran to start the session. Over to you, Kiran.
Hi. Hello, everybody. Thanks for the nice introduction, Omkar. Hope I am audible, clear, audio is clear? Yes, okay. So I will start sharing my screen now. Yes, visible?
Yeah.
Okay. So welcome, everybody, to this workshop on creating presentations using LaTeX. So I got to know that in March 2022, Karili had a workshop on LaTeX. So I went through the video also. So it involved dealing with mathematical equations, typesetting a document in LaTeX, and table and many other things were there. But this is one particular package that I'm going to discuss today is called the Beamer. Beamer is that document class or a package in LaTeX which is used to create presentation slides. Okay, so I hope that many of you are already familiar with LaTeX. Even if not, don't worry, because I will be telling what are all the features of LaTeX which are common for Beamer as well as the article format. So I will be telling those things. So first, let me tell you that LaTeX is suppose you are an artist and you want to create some kind of creative presentation. In every slide, you want to create an animation. You want to design every slide in a different way. Every slide. Then probably this is not the software that you would use. So this is more of a technical oriented. This is for those people who want their content to be the forefront of their talk, and also if with minimal effort, if you want consistency And if you want a neat, clean presentation, which can be viewed from even a far distance, you usually will be presenting it to an audience, probably sitting in a hall. So for those kind of people, this would be ideal. So that is why we are having this discussion. So my talk is yes.
There's some disturbance from your side, like this mic issue maybe.
Is that so?
Yeah.
Okay. Now?
Your voice is echoing actually. That's the.
My voice is echoing. Just open the windows. Okay. Just 1 second. I will try to reduce my. Yes, how is it now?
Yeah, it's clear now.
Is it okay?
Could be more, little bit more louder.
Okay, now?
Yeah,
is it okay?
Fine.
It's fine?
Yeah.
Okay. Yeah, so as I was saying, this particular LaTeX and the Wiener package of LaTeX is for those people who want to show their technical information, especially mathematical equations, expressions, or theorems, or tables and graphs, where you don't have to worry about the rest of the, the landscape of the slides. You don't have to worry about, what color is what coming in and nothing like that. You can choose one color and let the software take care of the rest. So this is for that kind of, users. So my talk for today will be divided into 3 parts. So in the first part, I will take around 10 to 15 minutes and I will show you how, let's say a typical, presentation using LaTeX will be. I will show the different features of LaTeX and I will show what all you can do. As per my knowledge is concerned, I will show you what all you can do with LaTeX. So we will be touching few features in that. Then the next part is going to be the longer session of hands-on, where I will create this presentation. I will use all the features and create this presentation from scratch. I am not using any template. I will tell you how to install, or if you are using Overleaf, I will tell you how to do that. So every line will be typed and you will be understanding every line that you are going to type. No encryptions there. Then maybe we'll have some 15 minutes for question and answer sessions. I'll try to answer if possible. I'll try to answer your questions.
So participants, kindly wait. Let me just try to connect to Kiran. Looks like he has got disconnected.
Hello. Yes, am I audible?
Yeah, no.
Yeah, sorry for the interruption. So yeah, again visible. Yeah, okay. So I just want to tell you that this presentation right here is created using LaTeX. I'll just quickly mention the features of this. This is the title. Okay, this is the author, institute, date, logo, and the short versions of author name, institute name, and your title will be appearing in the bottom line, the bottom bar. So it will depend on what kind of themes you use. So So where these things will appear will depend on what themes you use. But once you define something as an author or a title, you don't have to worry about it. So I'll just show you a few examples. So this is another theme that I have used. So I just want to mention that with one change of word, you can change the whole theme of the whole presentation, and it will look something like this. I will give you another example. This is one of those, or something like this, or something like this. So it has something like who, from, when, and everything. So, or something that I started with. And also you can change the font of the entire presentation by changing one word. So there are commands which we will be discussing later. So you can see there is a big difference in all the fonts have been changed into something else. Now this have become italics, you can see. So back to the first one. So these are the themes. These are related to themes and font themes. So there are a list of themes and font themes that you can choose, and you can create your presentations. Now, this is how a Beamer slide with a plain text would look like. Okay. So here is the title bar. So whichever title you want to give to your slide, it will appear here in a big, this one. Make sure that every slide will have a title. Even if you are continuing the talk, make sure that this title is always there, so that suppose somebody misses something in between, then they can come back and really look and see that this is what your topic is right now. So the default font size of a Beamer document is 11 points. So this font is measured in points. So 11 points is the default size, font size. You don't have to change it for Beamer. Maybe for your report or article, it's okay to change it, but Beamer recommends that you don't change it for a Beamer document, because it is set in such a way that it can be visible from, in a bigger hall from a far off audience. So you can see, like it is recommended that you don't write a lot of lines in one slide. Okay. Even if you have a plain text, please limit it to around 10 lines in a frame. Okay. And make sure that text is revealed piecewise. Okay. So if you are talking about one topic, let that text be revealed in that particular instance. So you can see how from here this text got revealed. In the same way, I just want to mention at this point that Beamer is not of the YCVig approach. YCVig means what you see is what you get. So suppose you are creating a document in PowerPoint or any other software like that. There you will actually drag and select and make something into bold and do something, and whatever you see is the output of that particular document. Whatever you see is actually what you get. But here we will be dealing with a text file which is called the .tex file, which is a piece of code, and the text compiler, the LaTeX compiler, will compile it and give you the output that you are seeing right now. So this is not of the approach of YCVig. So you can say what you see is not what you get. So here, for you to be more clear, you can use the section and subsection commands. If you can see on the top bar, you can see the section on one side and subsection on the other side. I hope you're able to see that. So now coming to the next part, like as I already said, plain text is not recommended when you're presenting something. So it is best to use some lists, maybe numbered or not numbered. And also it is convenient if you reveal it piecewise so that the audience is with you all the time. So I just have made a list, a numbered list, which lists out the requirements to create a LaTeX document. There are mainly 3 requirements. One is a text editor. It could be your Notepad, but Notepad would be too simple. Please use something called Notepad++ or Visual Studio for Windows users. Linux people can use Vim or something like that. You need a LaTeX compiler which will compile this file So the softwares that are available for this kind of compilation are TechLive, MikTeX, TechStudio, so and so on. And you will need usually the output of a tech file will be a PDF. You can create other kinds of output as well. You can create a PNG if you want, but usually the thing that we will use is PDF, whether it's for an article or for a presentation slide like this. You should observe that this, even though it is appearing like a PowerPoint presentation, the format is PDF, so that if you change from one computer to another, nothing is changed because it's a PDF, it is constant. Then I have just listed out a list without numbering, okay, second item, and an itemized list inside another list. So you can do such things. You can do it up to 4 times, sub-list, sub-list, but it is best to limit it to 2 to convey your ideas. So I have put one equation just as an example. This is the Schrodinger equation for a non-relativistic particle. So you can see that math is very neatly typeset. And today we will not be dealing with a lot of math because we will be more focused on how to create a presentation. So math we can discuss later, or I can refer you to some manuals or something which you can refer to. But this is how a mathematical equation would look like in a Beamer environment. So I got to know most of you are mathematicians, so you will be presenting a lot of theorems. So you can have this block for theorems, where in one block you will put the statement of the theorem, and in another block you will put the proof of your theorem, so that it is highlighted and it is much more appealing. So proofs can be given using mathematical expressions like this, something like some equations, or using lists like this. So if you use a proof block, it will automatically give the end of proof symbol. So that will be convenient. So we will be discussing one theorem later also. So this is how you might like to use, present a theorem. So you can also insert tables, but make sure that the table is not a very big table where nobody can see. A tiny table with a big font, which is readable, could be some random table I have put just as an example. The list of countries and codes I have put. So another thing is, now you may want to insert certain figures into your presentation. So this is how a frame with an image and a caption would look like. So I have put the photo of the developer of tech, the founder, Donald Knuth. So this is just a slide with one image and one caption relating to the image. You may see that this slide might appear a little empty. You have a lot of space, you want to use it, you want to convey a little more information. Then you can use something called the columns environment. So columns environment is used to divide this slide into 2 parts, where you can put figure on one, on information on another, or in whichever way it is convenient, you can put your information. So another interesting package that I will be just touching, I will be grazing upon is something called the TXZ package. TXZ in LaTeX is used to draw high quality images using codes. So here there is no drawing, no pulling, no stretching, nothing is there. Whatever you want to convey, you will be writing a piece of code which will be compiled and will be producing something like this. So just to give you an idea, this I have taken from one of my annual presentations. So I was dealing with something called 4-mode screw state, and we will consider either one state or 1 and 2 state, 1 and 3 state, and we will be performing photon additions and subtractions. So just to convey that idea, I made a transition which will look like this. So only first mode is considered, and either photon is added or subtracted. Only first and second modes are considered, where photons are added or subtracted. First and third modes are considered, where photons are added, subtracted. So by using transitions like this, you can convey your idea in a better way. And so you can use all your creativity, but you have to learn little piece of codings. You have to learn. There are many tutorials available, many manuals available for you to do so. So we will be just touching upon this topic. And one more thing I would like to show is the animate package. So yeah, PDFs, if you are reading the PDF using Acrobat Reader, it will also read animations, and these animations can be created by using codes in LaTeX. So I will just replay it for you. This is a ball dropping. So there's a ball inside a box dropping a ball. I hope that is smooth enough to get the feel. So I will be sharing the slides so you can look at it later also. In the next slide, the ball is staying upward, it is staying right there, but the box and the girl are moving. So this was, so me and my friend were doing some presentation where we wanted to convey the idea that this motion itself is relativistic. So it is so relative that for the girl, both these experiences are the same. So that's the idea we wanted to convey. So this is about the animate package. I will just show you a piece of code. I will share it also, so you can explore later on. So, and also just to give an idea of how you might produce, present a theorem. I have taken a very basic high school theorem. Omkar suggested it to me, so I have taken it and I have tried to present it in my own way. Please use your creativity to make sure the idea gets conveyed in a better way. So you can see that already I have put the section and subsection names. So this is the section of basic proportionality theorem, and subsection is the statement. I have given only the statement in this particular slide. In the next part, I'll be going to the proof part, where given, I will say in triangle ABC, where only this triangle appears. Then line L is parallel to line BC and it intersects AB and AC. When this piece of information is revealed, this line is also revealed. So, and in points P, point P is highlighted and Q respectively. So what I'm going to prove is AB by PB is equal to AQ by QC. That is the proportionality here of the sides. So construction draws segments PQ and segment BQ. This is the construction that you're doing, so that's why it is in the dashed lines. So whenever I open the construction, that piece, this will also be revealed. So how to do something like this will also be dealt with in the next session. So then you can keep a tiny image for reference for your audience. Then you can start go on like this with the proof. You can reveal it piecewise, and then finally you can come to the conclusion of this. Okay. So this will be the end of my talk. I don't have any more slides. I don't have any more slides. So this is the end of my first part where I have introduced certain features. So now I will be beginning with the very basics. So for now I'll be closing this, and yes, I hope everything is visible. So yes, one thing that you need for a LaTeX document, to create a LaTeX document, is first, please make a folder. Okay, since we are going to discuss this, I am going to make a folder called discussion. Okay, inside that folder, you have to create a text file. So I will be doing it in the terminal. You can do it in a notepad or any other way. So discussion.tex. So all the text files will have the extension .tex. Please observe. Then it will open something like this. Okay. So this is a blank text document. So the way I will be compiling this is by using a command called pdf LaTeX. Okay. pdf LaTeX discussion.tex. This is my compilation command. So just for those people who are using Overleaf, I will just open it also, and I will just show you how to do it in Overleaf so that you can follow. If somebody wants to try it out as and when I'm presenting, that they are also welcome. So if you log in to Overleaf using your Gmail, then you will be going to this particular page. After you log in, here you can click on new project and say blank project. You can give the project name. I'll give the same project name. Yes, so it is open. Now you can see but it has created a folder called discussion. Inside that, there is a main.tech. And inside that, this is the text part of the file. This is the .tech file that you will be seeing. And the output of PDF is also visible on the right side. So people who are already familiar with Overleaf, you know all these things. But people who are doing it for the first time, please know that this is the program which will be compiled by using this button, and the output will be visible here, which can be downloaded using this button. So this is the basic feature of Overleaf. So now I'll go back to my editor. So the editor that I am using is called the Vim editor. So I just will save this. And so now let us start with the first feature. So a tech file, whether it is an article or a Beamer presentation or report or whatever, it will have mainly 3 lines. So I will be giving you those 3 lines. One is, the first line is called document class. So inside document class, sorry, spelling mistake, document class, you can write article. Since now I am doing a Beamer presentation, this is our document class is called the Beamer. So document class Beamer. Then there will be a begin document. Okay. End document. Okay. Now I can just compile. I hope, yes. So since I have not given any content, there is really no pages of output here. But now I will just type begin frame and end frame. Okay. So now if I save and compile this one, you will see that in this particular folder, it has created a file called discussion.pdf. I'll put it to full screen. So now I'll be switching back and forth between this editor and this document viewer, so that whatever input we are giving, we'll be simultaneously be able to see the output. So just by using these 5 lines, we have created a PDF which has a blank page. Okay. Now we will see, like, whatever you type in between, let's say you want to type your text here. Okay. Now if you save and compile, that part, that will be appearing here. Okay. As simple as that. Now you always need a title for your frame. So the way to do it is, you can say frame title and say my first slide. Let's say Beamer slide. So this will be the title of, yes, you can see that the title is already there. In the same way, you can use frame subtitle and it will give you a subtitle. Okay. So these are the things that we will be doing. So another way which you can create this frame is, you say begin frame, end frame. Make sure all the brackets, since this is like a code, you can't even miss a bracket. It should be very proper. So instead of giving frame title, I'm just typing it here. Okay. Begin frame, my second Beamer slide, end frame. So you will know that there is no difference as such. Okay. My second Beamer slide will also appear in the same way. Okay. These are 2 ways in which you can enter a title for your presentation slides. Now, so whatever comes after document, so document class Beamer or document class article is always the first line that you will be typing in your tech document. So whatever comes after document class and before begin document, this part is called the preamble. So this is not nothing related to the content that you are showing. This is about importing certain packages or defining certain things. So all they are called macros. So all the definitions of macros will be done here before you begin the document. So now this works only for Beamer, not in the article. You can say use theme and I will use the same theme that I used for my, it's called Cambridge US. There's a list in the website, you can refer to it. So Cambridge US is one of the themes, one of the names of the themes I have used. So if I compile, you can see that the theme has changed. Okay. So now that first slide and second slide are done, now we would like to include our main slide, the first slide, which has the title, author, and everything. So I will define title. As I said, all these definitions will come before the begin document. This is the begin document. So before that, I am defining the title. So title will be, let's say, same thing, whatever I have given in the first, creating presentations using. So the way to get that particular LaTeX symbol is like this. Please observe. It's a slash. So you will be using a lot of backslash in LaTeX. So people who are familiar will know that whether it's a Greek symbol or whether it's an up arrow, down arrow, whichever command you are using, begin frame, end frame, you will be using this backslash all the time. And this is a defined command in LaTeX. So L caps, A small, like that, it will go. And with a bracket, will give you. Okay. Now I have just defined the title. Now I will say slash author. Okay. So your name should come here. Okay. Then institute. Okay. So in the institute, I will just type my institute's name. Then there is a date command where I can use. So slash today is the command where if you compile it today, it will put to today's date. So the day of compilation will be taken to the date. Or you can write your date, just like October 29th, 2022. You can write like this. Let me put slash today here. So for all these versions, we have a short version which can be given in a square bracket. You see that this was given in a curly bracket. So this is given in a square bracket. So for title, I will say Beamer. This is the short title. For author, I will just give the initials, just initials, then the short form of the institute name. So all these things I can give. And you would always want your first slide to be your title slide, right? So I will create another begin frame, end frame here. And I will say title page. Now it's ready to be compiled. Now you can see what is the missing begin document. Okay, one second. Some error. Okay, yes. This I should have given in the square brackets, the short version of the name. Yeah, so you have to be careful with the, again, same mistake, sorry. Short versions are given in square brackets. The longer version, the full versions are given in curly brackets. I hope it compiles. Yes. Yes. So this will give you the first slide, which is your presentation title. So now from here, I will, there is a logo which I want to put in my first. So I will just copy it to this folder. Make sure that wherever this text file is, there all the pictures and all the images whichever you are putting, so it should be in the same folder, so that if you just mention the name, it will compile and give you the okay. Now I will say these are the tiny commands which you may have to remember for include graphics. So people who are already familiar with LaTeX, they will know that this include graphics comes as a command for GraphicX package, where so here you can mention the height or the scale of the image, and then you can mention the name of the image, which is logo.png. So the moment I say title graphic, it will come in a particular spot. So according to the theme, it will come in a particular spot. Maybe for a different theme, it will come in a different spot. But for this theme, it is coming right over here in the center. So this is how you would insert a logo of your institute. So instead of writing title graphic here, if you write /logo, then it will give you a logo on every page here in the corner. You can customize it, of course, but it will give you a logo in the right bottom corner. So this is mainly about, okay, the title page and all these things. Now we will just type some text and see. So I will type my first line of text in one of the frames. So I'm typing it here. So my second beam slide. My first line of text will come here. My second line, sorry. Okay, my second line of text will come here. Now, as you can see, I will discuss few topics here. Okay. Oh, okay. Yes. So in the third slide, which is so first is the title slide, second is my first beamer slide, and third is my second beamer slide. Here, first line of text and second line of text has come. Now you can see that this is aligned to the center of the page. Okay, vertical alignment is center of the page. Now you can change that by just saying after frame here, if you say C for center, that is center. If you say T, okay. Oh, sorry. Over here, if you say T for top, yeah. So the alignment will come to the top of the page. So based on your convenience, your requirement, you can align it to T for top, C for center, or B for bottom. Okay, maybe bottom you will never use, but anyway, I'll show you how it might look. So all the text will come to the bottom alignment of the page, which, yeah, we may never use. Let's see. Let's put it to top for now. Okay. So this is one thing. Now another thing is, I don't want both these lines to come all at once. As I said, it is very convenient to reveal these pieces in chunks, in piecewise. So what I'll do is, before this second line, I will type a command called pause. Okay. Now, if I compile it, so first line of text will come, then in the next slide, second line of text will come. So how this animation or this transition is happening is in PDF is, it is actually creating two pages, exactly similar two pages with the same page numbers. But here only first line is there, only second line is there, so that when you put it in full screen, it will appear as if it's a transition. Okay, that is the use of this command called pause. You can use this pause for when you want to reveal things in piecewise. Okay, now the next thing that I discussed in yes, the next thing that I discussed was this thing called lists, right? Whether it was numbered lists or not numbered lists or bulleted points. So whichever way you want, we will see how to do that. So using lists. Okay. So this frame name will be using lists, and you can start with something called the enumerate environment. So as usual, there will be a begin enumerate and a end enumerate, and in between /item will type the first item for you. So this is the first item. Okay. This is the second item. Okay. So now if I compile, yeah. So lists, this is the title. This is the first item. This is the second item. Okay. Now, let's say you want to make this item appear only in the first slide. Then use something like this. These are the angle brackets. Okay. So this is the angle bracket that we are using. So here I will say slide number 1 and beyond. Okay. This will come slide number 2 and beyond. Okay. If you do this, then you can see that these lists will also be revealed piecewise. See, only first item came. When you click the next button, the second item will come. So if you want to make it a bulleted point instead of enumerate, I will just take this same thing and change it to itemize environment. Itemize. Begin itemize, end itemize, and in between there are items. Okay. Now you can see that the numbers are gone, only bullet points remain. These can also be revealed piecewise. Now, obviously, if you want a list inside a list, then you are going to type the same itemize inside the list as another item. So here, list inside list. Okay. So list inside list will come. You can have many sublists as per your convenience. And here at this point, I want to share one thing which is called the alert command. If you say /alert and in brackets, if you type something, you can see that it appears in bright red so that it is highlighted in a way. Okay. But if you want it to be highlighted only in the second slide, let's say, then you type this angle brackets 2 hyphen so that slides 2 and beyond, it will be highlighted. Okay. Here, this is the first item. When the second item comes, the first item will be highlighted. Do it as per your convenience, your requirements, you can do it. So this will be the usage for alert and item. So item will also take this particular parameter. Alert will also take this particular parameter. Okay. There are different ways to do this, but this is one of the widely used ways. When it comes to figures and all, I will discuss another way to do this kind of transitions. So right now we will type another slide. Okay. Mathematical equation. Okay. So this is a frame in which we will be typing some mathematical equation. So suppose you start with something like begin equation and end equation. Okay. If you say begin equation and end equation, this will give a numbered equation. And you can see if you type something as A is equal to B plus C, very simple. Even then you can see that it comes in a different font. So there is something called the math font which the LaTeX uses. So this is not the same as the ones that you'll be using. So this font and this font are slightly different. You can use a particular font category or font family for just mathematical expressions. You can change it however you like. So here, this is, you can see this is a more of a italicized version of this, which will be defining the variables. So people who are already familiar with LaTeX will know this, that all the variables are defined in a slightly different way, so that you won't get confused between the article A and the variable A, something like that. So this you can see is the numbered equation. Okay. Now I want to type something like inside a text, inside a line, I want to type some mathematical equation. This is proportional to, let's say, a squared plus b squared. I want to type something like x squared plus y squared. So in this, if you simply type x squared plus y squared, the compiler will not recognize this. All the mathematical expressions, especially inline mathematical expressions, should be, enveloped between this dollar symbol. Okay, so this dollar symbol, front and back, you put it in between. If you type a mathematical symbol, expression, you will see. Okay, so you can see the font is different. This is proportional to x square plus y square. If you don't want a numbering for this equation, then after equation, just type a star here. That will simply remove the equation number from the equation. Okay. Yes. Yeah. Okay. So I just want to mention at this point that this begin equation, end equation, and typing mathematical expressions in line, all these things are same in the article format also. Okay, there is no change. If you simply copy this code and put it in an article, it will appear as it is with no problems. Okay, now when it comes to my plain text, I want to discuss few more things there. Okay, I'm just coming back to that slide where I have typed just the plain text. So I want to type, this is an italic text or italicized text. If I want to type something like that, I just have to use the command text it and then a bracket. In brackets, I have to type the italic text. Okay. If you want to type something like bold text, this is bold text. Okay. Then it is text boldface, text BF, and then close the bracket. So you know that there is a font called small caps which we might be using. So text SC for small caps will give you small caps, and this is typewriter font. Okay, so text TT will give you the typewriter font. I just want to mention all this and also show you how different it looks. Okay, yeah, you can see this is the italicized text. Sorry, the italicized text, bold text, small caps font, typewriter font. Okay, so these are the commands which we'll be using. Now let's go to one more topic, which is so before going, is everybody okay with the speed? Do you want to slow it down or any questions?
Hello.
Yeah, hello, yes.
If we want to, in the title page, if we want to avoid that lines like Beamer or date, what we can do?
Okay. So in the first slide, this one, you don't want it.
Yes.
Okay. If you don't want this entire slide, so in entire line, then you can use a different theme. That is one of the options. Okay.
Not the entire line.
You just don't want this text here. That's all right. Hello.
Hello.
Yeah. Tell me. You just don't want this text, right? This particular texts that are coming. Yeah. Okay. So for that, what I showed you here when I'm defining this is the short version of the title, right? So
yes.
here, what you can do is this short version, you can leave it blank. Okay. So that nothing will come. when it so that those spaces will remain empty. See, you can also remove the date if you want. Okay, so title, you need the title, but you don't need the short title. So you can leave the short title, that part empty, the square brackets empty. Okay.
What I meant is to avoid only that center part, like that beamer coming like beamer.
Only the center part. Which center part? Here, right?
Yes. I need the left half actually, that name which comes.
Oh, okay. Then, as I said, here, so that was the title actually. So that was the short title. So I used it as Beamer because we are creating presentations using LaTeX. So that's a Beamer package. So it is not a Beamer as a, it's not like a watermark as you would imagine. So actually, this particular set of softwares, they belong to the free software category. So nobody uses any watermark, no copyrights. So as a funny mocking way, they call this the copyleft agreement, where you can actually distribute it however you want and change it however you want.
Oh, okay.
Okay. So if you create something, if you create some content using this, it is totally yours. You don't have to owe it to your, the software that you have created it to. Okay. So your short title can be anything. It doesn't have to be Beamer. Okay.
I thought it's automatic.
No. There's nothing like that. So every single feature of this particular document is customizable. You can change the color, you can change the way it looks, you can change what appears and what not. Everything can be changed. There's no problem with that. Okay. So yeah, one more thing I probably forgot to mention was like we were using this overleaf, right? So just this overleaf has this particular tech part, which is the text, this one. So whatever I'm typing here, just copy this and paste it to this and compile, you will get the exact same output. You don't have to worry about, so based on the compiler, nothing will change. So even the overleaf compiler or the text studio compiler or your software that you have installed, all of them will give the same kind of output. And yeah. And also one more thing I wanted to know is, I wanted to tell you is that this is a basic text editor. Okay. This is like just like a notepad. But if you type it in Notepad, obviously you won't be seeing these colors. So there is a maroon color, there is somewhat of a blue color, black color, or green here. You won't be seeing any of this. So it will become little difficult when you are typing. Just to show the difference, I will just put the syntax thing off. Okay. Syntax off and see. So this is just plain black. So whether you have made a mistake in the command or which is the command, which is the this one, nothing will be clear to you. So that is why all the editors of tech, usually this is a very common thing with the programming languages also. Nobody uses plain black text for writing a code. Same way, the moment you type the .tech as the file name, this particular editor has recognized the patterns, recognized the commands, and it has highlighted those syntaxes. Okay. So usually usually it should be on. So let's say syntax on, it will appear something like this, which is much more convenient when you're typing such document. And as you can see in overleaf also, it is already done. Okay. They appear in different colors. If you go to text studio also, you will observe the same thing. That's just one thing I forgot to mention. So now we will be just we'll create one. Yes, please.
How to center the image? You have added including graphics package one image. So how to do it center or customize it right to left, or how to do it caption some figure?
Oh, yes. Okay. So inserting figure. Then I will just discuss that part first. Okay, right now. Okay, so I will begin frame, end frame. This will be a frame with a picture or a figure. Okay, so for this, I will be using one command called include graphics. Okay, include graphics, and the name of the file. So I will show you what is the name of the file where I am taking it from. So I have a file here called dek.jpg, which I showed you earlier. That was the the founder's photo, dek.jpg. Okay. Now I will type the same dek.jpg here. Then I will write the scale as 1. Okay.
It is the original size, right?
Scale 1 means original size. Scale 1 means original size. Okay. Yeah. So you can see that it is left aligned. So in whichever way the text is aligned, so you can see here and all, the text was aligned to the left. In the same way, the figure is also aligned to the left. Until you change it, so nothing will change. Okay. So now you understood that. Sorry. This much of big image is not needed. So now you can change your scale accordingly. Okay. Your scale is, let's say, 0.6, and you can just compile and see how it looks. Okay. Now this is a perfect size for this particular frame. Now it is not in the center. Okay. Now if you say begin figure, end figure, so there is something called the figure environment. Okay. So the figure environment will make sure that your image is center aligned and it will appear in the main part. So what you said about left align and right align, usually it is not recommended. Okay. You can actually force it. You can actually say there is something called begin right align, begin left align. There are commands like that, but usually we will not be using it. Okay, we will be using begin figure, end figure, so that wherever the image is, it will come to the center. Suppose you are writing an article where you want to wrap your text around the image. Then there is something called begin wrap figure, end wrap figure, which will take the text and wrap it around the figure, so that it will appear much more appealing. Whether you want to wrap it from the left or right, all those options will come there. Okay, for that you need to explore a little, but this much is the basic for including a figure. This much is the basic. Begin figure, include graphics, and end figure. This should be the basic.
One more question: how to give the caption in some figure?
Yes. So as I said, there is a environment called begin figure and end figure. This will take two more commands. One is the caption command. Okay, caption, and I will say this is Donald North. Okay, this is the caption. And another command it will be taking, which is a little out of the topic for today's talk, is something called the label. Label, you can say something like fig dk. You can label it, and you can actually refer this particular ID, fig::dek. You can refer this ID and you can use it. So if you are saying somewhere in the rest of the document you are saying from figure 4, so that 4 will automatically come if you refer to this particular figure. I mean this particular label. So caption, as you asked, I will just show you how the caption will appear. Yeah, this is the caption. Okay. Yeah. So after this, now I will be going to one more like this thing, which is the table. So how to insert a table? Okay. So one thing to note here is that the commands that you will be using are very intuitive. So if you say begin figure and end figure, that's the figure environment. In the same way, obviously it's the begin table and end table environment. Okay. So first I'll type a begin frame. I'll type an end frame again. Frame with a table. Here I will be typing a begin table and end table. So the way I inserted this include graphics, okay, without anything. In the same way, I can include the tabular. So there are two things here. I will explain it to you in detail. So even without this begin table and end table, this will work. But to make sure that everything is aligned to the center and the computer, or I mean the software knows that this is a table. So you create an environment called the table. Okay. So table will again have caption, will again have label. So that's why you create a table. Now, the various elements that you give for a table will come in a environment called the tabular. Begin tabular, end tabular. Okay. So when you say begin tabular, here in another curly braces, you have to specify how many columns you are planning to give. You don't have to specify the number of rows, that you can decide later. But the number of columns that you are giving should be specified earlier. Then, if you say L, L is for left aligned. Okay. So I will have 3 columns in which all the elements are aligned to the left. Okay. I can have L, C, R, where it is left, center, and right. So the first column is aligned to the left, second column is aligned to the center, third column is aligned to the right. So right now I will just start it with, let's say CCC, where all the tabulas are, all the elements of the table are aligned to the center. So now my first, I will give a name. I will say and is to separate the column. Okay. And is to separate the column, name, and then I will say a number, and then I will say a year. So these are the 3 things that I will be having in my table: name, number, and year. So to go to the next line, I just have to type double backslash. It will take me to the next line. Take me to the next line as in take the table to the next line. It will start typing in the next row of the table. So first I will type the name Kiran, then I will type a number which is something like 21, then I'll type the year which is something like 1994, then I will type going to the next. Now again I need one more name, so let me type Omkar's name. I'll type 23, I'll type 2022. Just some random, this one. So this much is enough for me to create a table, but you will see what is the output and what all need to be changed. You'll be able to see. Okay, so this is a table. This is the tabular. Tabular means this it's like a matrix. So whichever element you give, it will come here. It's like a matrix. So name, Kiran, Omkar, like everything is there, but there are lines missing. So to make sure that it has lines, here itself, to have this vertical lines, I'll be typing these pipe commands here. Please observe. So left, middle, center, right, wherever, like all the, how many pipes, lines you want, those many vertical lines you have already drawn here. So what it will give? It will give me these vertical lines. Okay. So the moment you say begin tabular, you can start with something called the H line. which is the horizontal line. And you can go on giving horizontal lines wherever you want to cut the table. Like wherever you want to draw the line, you can go on typing H line. Sorry, just one something is there. Yeah. Yeah. So all the lines have come just by using this pipe symbol 1, 2, 3, 4 here, and by using 1, 2, 3, 4 H lines, all the things have come here. So to distinguish between the heading and the rest of the content, maybe I want to give H line twice here. Okay. H line, if I give. So there are other ways to do it, but this is one the basic way that I'm discussing. It will give 2 lines. Okay.
How to bold the contents of the first line like number, name and year.
I think there is some internet issue from the speaker's end. Let's wait for some. Sometimes you can ask your doubt and delete them.
Yeah, so I think I'm back online, but I'm unable to share the screen. Can you?
Yeah, you have joined with a different device. Yeah.
Yeah, is it visible now?
Yes, yes.
Yeah, okay. So I think somebody was asking something.
Sorry, sir. I have a question. How
Yeah,
to
yeah.
bold or how to change the color of the main line, that is name, number and year?
Oh, okay. So yeah. So actually, to change the color, there is something called the package is called X color. So right now I don't remember the commands for X color, but yeah, any this one X color. Like, do you know the commands? Okay, so no problem. So I'll just tell you that maybe I can just search it because. So Xcolor is the package that is used in LaTeX. Use package color red. Yeah, okay. It's as simple as this. So in the preamble, I have to use package.
So the participants kindly wait. Kiran is trying to rejoin. Also, you can use the chat option if you have any queries. And one thing maybe I would like to add is just now, I think Saptak asked something and Kiran did not know that particular command. So he just went to the internet and searched it. So the site that we opened was overly. And if you guys are also trying something, if you don't know anything, you can also do the same. Just search this thing on internet. You go to the overlay site and at least 90% you will get your answer over there. So something that I would also suggest. Also, as Kiran told us, you can use overly. It's free. You can just go to that site, create an account, and start typing this code, whatever Kiran is typing, in that text editor, so that you don't have to download any software or packages. Okay, yeah, Kiran is back. You're muted, Kiran.
Can you allow me to share screen?
Yeah.
Yeah. Yeah. So as I was saying, so for the first time, I am using this command called use package. Okay, this is a command to import. So even when you are doing a certain programming like C or Python, you will import certain libraries, right? In the same way, in LaTeX, you will use certain package which is required for the present document. So that is called use package. You type X color. Okay. Now, so somebody wanted to know how to give this. I am typing text color blue, and I'm closing this. I think this is the way. I'll just check once again. No, just color red. Yeah. Color blue. So instead of text color, it's just color / color blue and name. This will give you okay. That blue should have been small blue, small b. Yes. Yeah. So this will come as a color in whichever color you want to give. So I just want to tell you that LaTeX has this little interesting way of mixing these colors. So let's say you want 80% of blue mixed with 20% of black. You just say blue exclamation 80 exclamation black. So 80% of blue will be between. You can see the change in color. It became a darker shade of blue. In the same way, you can mix it with white, blue. So like if you mix blue and yellow, you will get green. So obviously, you can try it out. You can have green also. Green is also a defined color. But just to show how this name mixing and all will come, I'm just showing you. Okay, let's say some 40% of blue. Right, some color will come in that way. Okay, so in this way you can define your own colors. So I will just say blue for now. Then for another one, I can just say / color yellow. Just another example, so that this blue and yellow will come like this. So please use the colors which are actually visible. So this yellow is a very bad color to use in a slide. Nobody will be able to read it. So let's use some colors which are dark and visible from far. So yeah, I think I have done like tables. Tables is okay. Now, even in the table, as I discussed this alert thing, so I want to highlight a certain text. So I am for Kiran, I am highlighting it in the first slide. And as far as this second name, that is Omkar, I am highlighting this one in the second slide. You can see the commands I'm typing over here. So the result will be, so first slide, second slide. You can see how this is highlighted in the first slide. This is highlighted.
We can also use using the pause command, right?
No, pause is only for something like a text or an equation where you have to reveal it piecewise. Okay, you are revealing your text or something piecewise, then use the pause command. For the rest of the things, it is and usually to avoid confusions also, it is very convenient to use this angle brackets and specify the slide number. That will be much more convenient. So I will be discussing something called on slide in the next few minutes. So there also you will get to know that this is more convenient. Okay, pause is when you have a linear text and you are only revealing it piecewise. You are not going back and forth. Okay.
But in pause command, they will be in same page, right?
Sorry, I didn't get you.
They will be in the same page, means some certain number of pages.
Yeah, pause command also will be in the same page, but again I want you to note that Beamer has created two pages, one where this Kiran is highlighted, one where Omkar is highlighted, and it has kept it with the same page number consecutively, so that in full screen it will appear as if it is transitioning from one name to another.
Okay.
Is that okay? Yeah. So it is definitely convenient to use, that angle brackets and specify the slide number. So the maximum number of slides will be the maximum number you have given. So here you have given 2. So 1 and 2. So there will be only 2 slides which will be created. Suppose here I will use the same thing and say this will be highlighted in the third slide. Okay, if that is the case, then it has created 3 slides, one with this one, the other with second one, this is the third one. It has created 3 different pages where these individual things are highlighted. Suppose you want certain, like I think I've already mentioned it, but if you want them to remain highlighted, then you have to use one hyphen, which will say 1 and beyond, it will be highlighted. Okay, let me just show you. So it will come something like this. So here only Kiran is highlighted. Here Kiran and Omkar. Here Kiran, Omkar and 21. All those things are highlighted. So these are the things. As far as table is concerned, I think this is it. So next thing I'll be going to is how to use a column. Okay. So as we have already inserted a graphic here, you know, we have introduced this this image, and suppose we want to bring this image to one side and type something on the other side. So how to do it? That I'll be discussing now. So as I've already mentioned in my introduction talk, that can be done using something called columns. So this is a frame with columns. So you have to give 2 main commands. One is begin columns, end it with end columns. Okay. Hope these commands are clear. Next, this is the singular column, begin column and end column. So I am saying begin columns, end columns. This is the plural. This will be the outermost layer. Okay, this and this. So inside that, you can create 2, 3, 4, whichever number of columns you want. Usually it is 2. So let me just type another begin column and end column so that it is clear. Oh, sorry, and column. So now when you see a slide, you know that it has defined a certain width for the text. That means beyond a certain margin, the text won't go. So we are using that particular variable and defining the width of this column as 0.5 times text width. Okay, you can change it. And again, this is also 0.5 times text width. You just make sure that this 0.5 plus 0.5 doesn't exceed 1. Don't make it 0.5 and then 0.9. So the total becomes 1.4 and it will go out of the frame. You can keep it little less also if you want, but it is ideal to keep it, so that the sum of these two things are 1. Sum of these two things is 1. So I can keep it as 0.3 and 0.7 if that is the kind of table, like a column that I am needing. Now I will keep it as 0.5 and 0.5. Here, I'll just copy this particular figure, begin figure to end figure. I'll copy this code and I will put it in the first column. Okay. So this is the first column, the highlighted portion. In the first column, I have just included a figure. In the second column, I will just go to some, list or something like that. Begin itemize, end itemize. I'll just put it. I'll just copy this code, put it in the second column. Okay. Now, when I compile, yeah. So it has divided this particular slide into half, 0.5. So on the left side, I have given one image. Right side, I have given this text. What you can change it however you want. You can change it. So this is the frame width columns. So now I will introduce one more package, which is a very important package especially for people who want to code and design something or create certain technical images. So for them, this is going to be a very interesting package. So as usual, we will go to the preamble, and just before begin document, we will say use package Pixie. Okay. Pixie is the package that is used to draw certain diagrams. So I will say begin frame, end frame as usual. Then, so I have a pre-written code. You can see that here there is a begin figure, end figure. There is a begin center, end center. Then inside that, the innermost layer is begin text picture and Pixie picture. Scale is 1. Okay. Here is the where the codes to draw something will go. So there is a command called /draw, where using the Cartesian coordinates 0, 0 to 5, 0, you can use and put a semicolon. This requires a semicolon. And if you compile, yeah, so it has given a figure where it has drawn one single line. So don't worry about the actual coordinates, because this Pixie will draw a figure and align it to the center of the slide. So this is aligned to the center. Now, if I want to extend that line from 5, 0 to, let's say, 5, 5. So the image will look something like this. So this is the line from 0, 0 to 5, 0 and 5, 0 to 5, 5. So you can use, so in this, I just want to mention that you can use Cartesian coordinate system, 2-dimensional, or Cartesian coordinate system, 3-dimensional, or even polar coordinate system. You can use all these kind of coordinate system to define your points, and then you can play around with the diagrams. So let's say you want a circle at the end of, draw at 5, 5. You want a circle of radius 2 centimeter. It is taking 5, 5 as the center and radius as 2 centimeter. These are the only two variables for a circle. It will draw something like this. Okay. So now you can, when you are drawing itself here, you can fill the whole thing with red. The red circle. Okay. You can fill it with red, and then I think you can say shade, I'm not sure. Yeah, so if you say shade, it will give a shaded color for the. So in this way, circle, so suppose you want to draw an ellipse, so then you have to specify 2 radii for the ellipse. So in this way, there are many. So the thing that I showed earlier here. So this was drawn using the TXE package. This particular thing was drawn using the TXE package, and I will show you one more thing. So now you want the first 2 lines to come in the first slide. Then you use something called on slide. Okay, on slide 1 and beyond. You will draw a bracket here. Then this another thing will be on slide 2 and beyond. So now you will know that, oh, sorry. Okay. Oh. So the syntax is very important. So yeah, so in the first slide, only this will come. So only the first 2 lines will come because that is the first line we have highlighted here. So we have said on slide 1, draw only this part. So on slide 2, it will draw only this part. Okay. So it will come like this. Second slide will be something like this. So using something like this only, I drew all these diagrams like which I showed earlier using on slides. So there is a code which I can share. So for on slide, I have one particular code which I can share. Okay. Now we will very briefly we'll discuss the animate package. So this is actually a lot beyond this the scope of this talk, but yeah, I'll just show you how to. So you have to use 2 packages called in the preamble. You will be using 2 packages. One is the animate and another one is multimedia. Then there is one particular code which I have already typed. I will just copy the code and then I will explain that to you. So that's going to be the last slide here after in frame. It's this image. Okay, so this particular, so when you, especially when you have animations, you have to open it using the Acrobat Reader, which is Acro Read. Okay. As you can see, this animate slide, it's working now. So it has a code. Now I will just discuss the code. So, sorry. Yeah, so it starts with a begin figure and end figure. So this is the figure environment. And then the next environment that we are using is animate inline. Please observe, there is an animate inline. So this controls and autoplay are the commands that we have used here. So controls is this set of buttons. Autoplay is when you come to the slide, it will autoplay once. So that is the meaning of this word autoplay. Then we have used multi-frame and 14. 14 is the number of frames that we have used. And then we have drawn the ticks picture. Okay, we have drawn the ticks picture using this particular variable called R position, where R position is varying in every slide. 14 times it is varying. So that 14 times it is putting it in a sequential order, and then it is. So the image of the girl over here, which you can see, that is here, some sw.png that is included here. And the image of the box that you can see here is given here. Use as bounding box, a rectangle. Okay, the ball is an electron. So we have defined it as a node electron, and we have given it a, see, the position of the node electron is varying here. That's why node electron has that variable. Suppose we go to the next, the other one I was showing where the box itself is moving, then this bounding boxes variable will be changing. Okay, so you may need a certain preparation to explore this, maybe some tutorial or something. So there are manuals available for every package. So for Linux users, I'll just show you. It's very simple. Okay, so if a TechLive distribution is installed in your computer, you just have to type TechDoc and say Beamer. It will open the manual for Beamer. You can see it's a 248 page document. Okay, but for those like if you're not using Linux and if you're not familiar with this command line, just search the packages and the manuals available. You will get everything online for free. This is a free software, so all the packages and manuals are available for free. So in the same way, I want to just show you how this TXZ is done. So TXZ is actually some 1200 page package. So it has many things starting from, from drawing a diagram like this to drawing a mind map, drawing an algorithmic chart. So there are many things to 3D plots. So many things are there. So you use, you can explore and use whatever you want. You can just search, refer to this as a manual. This is not a reading manual. So nobody can, I think nobody can read, 1200 pages of a manual and actually by heart it. But whenever you need something, this is where this is the go-to manual. So you just search, let's say you want to do some 3D thing, then just try 3D and see what comes up. Okay. So you will find something in the same way you will be going to see. There's a 3D bar diagram, 3D pie chart. All these things can be used. Okay. So I was just, so yes, please.
Yes, actually, sometimes we also get some animations from Mathematica or BadLab. So how to import and run it in autoplay mode?
Okay, so the thing is, LaTeX has given this option of including multimedia in your file. Okay, so I right now I can't tell you the exact code, but I can tell you one thing. I'll just show you what it is just over here. So the way you inserted a figure here, like begin figure, include graphics, and end figure. In the same way, you can include a video or an animation GIF or whatever you want. You can just include it and compile it, but make sure that you always open with Acrobat Reader. Okay, so that will help you. So I have actually tried opening some video file using LaTeX. That works actually. But you just have to refer to how to do it. Like I don't have the codes right now.
Okay.
Yeah.
Okay. One more question also.
Yes.
Can we change the difference in between lines, like layout?
Difference between, sorry?
In between lines.
Difference.
You can just customize the lines, gap in between the lines.
Oh, okay, okay. So for that, let me go to the first slide itself here. So this is my plain text slide. Okay. Close all the unnecessary. Yeah. Yeah. Okay. So here, if you want to leave space between this, so you can see already that in this particular slide where I created, all these things are crammed into one block. You don't want this. You want certain gap between things. So there are two ways to do it. One is you can actually specify something called vSpace, okay, / vSpace, which is the vertical space, and you can say 1 centimeter. Okay, this particular vSpace can be measured using points, like just like that font size I told you, 11 points, 12 points.
Is it by default 1 semi?
Sorry?
Is it by default 1 semi?
Is it like 1 centimeter by
By
default?
default 1 semi.
I'm not able to hear you. Sorry, there's a.
Yes, I am telling. Is it by default 1 semi? What is the by default size?
Oh, there is no by default size here. So when you use this particular command, vSpace, there is no particular, like default size, default length. You can give any amount. You can give something like, like 0.1 centimeter or.
No, I am telling what I am telling. If we do not give the comment, then what will be the by default size?
No. This particular command will take one particular parameter. It will take. If you don't want to use it, then there is something called small skip. Okay, small skip. And there is something called big skip. These are already defined, especially this only works in the Beamer environment. Small skip and big skip, I will just show you, this compile and show you. Oh, I'm so sorry. Let me just close all the unnecessary things. This is causing little. Okay, so I have used the small skip and big skip. You can see that there is a slight difference. So from this italic to bold, it's a small skip. This bold to small caps, it's a big skip. This is a predefined, vertical space that you can use.
Hello, Kiran.
Yes, yes.
So am I correct in saying that if you specify 1 centimeter, then the spacing between the two lines, whatever is there at the beginning, will increase by 1 centimeter.
Actually, yeah, definitely. It will increase. No, but the thing is, if you use small skip and 1 centimeter, definitely it is going to add up.
Right. No,
yeah.
Without using anything.
Without
because,
using also,
think,
if you say 1 centimeter, actually it is a measurement, right? So like usually this is considered to be an A4 sized document.
Yeah.
So in that way, it is 1 centimeter. Where in a printed document, it will be 1 centimeter.
Okay, yeah.
Yeah.
Also, we have a question in the chat. So,
okay.
Can we use LaTeX to type Indian languages?
Yes, definitely. You can type. So there is something called XE LaTeX. I think if I have something, I'll be able to show you. Right now. No, right now I am not getting it. But 1 second, maybe. Yeah. Okay. So Kannada, yeah. So this particular thing is completely typed in LaTeX. Okay. So this is a Kannada article. So I typed it in some other word or some notepad or something like that. I typed it, but then I took the text and I put it into a LaTeX document. I'll show you the how it looks. So one main thing is the editor that you are going to use may not support your language. That is the first thing you have to know, because if you are typing something and the font appears like this, then you can't do it. So you open it with a compatible reader. So something like Pluma, which will give you. So here you can see this font is perfectly fine. And here you have used like after document class article, you have used font spec polyglossia, and then you have defined a Kannada font called Noto Serif Kannada. In this way, if you just Google search, you will get to know what are the things. So set main language to Kannada. So I have done it, and the same way we defined that title, author, everything was done in Kannada, and this was the final output.
One more question I have. Actually, sometimes after presenting one kind of slide, we need some references. So can we able to include some references as a hyperlink?
As a hyperlink. Okay. Yes, that's a very interesting this one. So now I will discuss like that footnote and hyperlink together, because I forgot to mention it. Okay, so good that this question is there. First I will mention the footnote. Okay, then I will go to the hyperlink. Yes, again I will start with begin frame, our usual. This is going to be a frame with footnotes. So this theorem is proved in something. So I want, let's say here, I want to add something. Is it footnote or foot side? I just forgot. Footnote. So slash footnote right here. Type slash footnote and write this theorem means which theorem? Let's say Pythagoras theorem. Okay. And textbook means which textbook? So I will write another footnote saying that this is a some NCERT textbook. Okay. So this one thing you can see. So here that footnote is mentioned 1 and 2, and accordingly it has come. So this is one of the things that you will be using. Another thing that which so somebody asked. Sorry, I'm not able to see the names or faces. So another thing which we'll be using is, so I am doing it like separate frames so that I can just give this document so that all the things that we discussed will be here. So this is going to be a frame with a hyperlink. Okay. Here, all the images were downloaded from, let's say, Google. Okay. Now I want to make this particular thing as a hyperlink, okay, which will open in your. So I will use some package called hyperref. Oh, sorry, it's called href. I will use Google. Then I will specify www.google.com. I think this should work. Let's see. Is the
www.google.com, that is the URL, right?
That's the what?
That is the URL. Whatever the URL you need to hyperlink, that should be there, right?
Yeah, actually, I'm sorry. This should come in the reverse order. Okay, first the website name should come, then the word that the keyword that should come. Okay, I'll just show you. So this is Google. You can see that the moment I go here, the cursor is becoming different. If I click on it, it will open in your default browser, that particular. Okay. So I just want this overleaf thing. So just copy this particular link. Okay. Here I create my documents on overleaf. Href. So if I click on overleaf, it will go to overleaf. So, and also this particular hyperlink that you have created, you can make sure that this has a different color, or you can have a border around it so that you know it's a hyperlink. So these are the options that comes with the package called hyperref. Okay. I'll just mention the package name right here so that it is clear. Hyperref package. Okay. So is there something else that you are asking, or is this, does this answer your question?
No, this is okay.
Okay, okay. So one more thing is, like all of us are, like research scholars, so we will be using bibliographies, right? So if you are familiar with the bibliography of LaTeX article or a report, then you can actually do it here. But one thing is, like it will appear like, like, square bracket 1, square bracket 2, which doesn't mean anything. When you are presenting a slide, this bracket 1, bracket 2 won't mean anything. So you just have to change the labels to author and year, so that, or you can use a footnote and refer it right there in the slide, just like I did it here. Using a footnote, you can make the reference, so that you don't have to go back to the bibliography section just to know which citation it is.
One more question I need to ask.
Yes.
Actually, say we are putting multiple equations, say equation 1, equation 2. So how to do the numbering?
How to do the numbering? Okay. Let me go back to. Yeah. So this is the equation. Here, if I remove the star, it's a numbered equation. Okay. Now I will type another equation. Some x squared plus some equation I'll type. So it will automatically come. It will automatically come as 2, like equation 1 and 2. Okay.
Here the dollar prompt is not needed.
Dollar. So dollar is not an equation. This
Because
particular
it
thing
is not in between the sentence, right?
It is in between the sentence, right? So it can't be numbered.
Okay.
Yeah. And also there are ways in which you can make your equation numbers take the section number also, just like 2.1, 2.2. You can make that also. So you just have to set a counter. Okay. So there are options to do that also.
Kiran, we are almost.
Yeah. So like whatever I needed to present, yeah, definitely I'm done with it. So if there are any questions, then.
Can we do the subsection using the subsection comment?
Using the what?
Subsection comment, section, subsection,
Yes, definitely. Here I have done it. I don't know if I have done it, but yeah, you can do it. So there is a, so in Beamer, in LaTeX, there is a section command. There is a subsection command. Okay, it will go up to subsection and more than that also, but section and subsection are included definitely.
Okay.
Yeah. Yes, are there any more questions?
So I have one question, like in the title page, can we add like subtitle or something? Like,
Yes, definitely. So just like here we used a frame title, right?
No.
In the same way, we can use a frame subtitle. This also works.
Okay. So it will be out of that box, right? My first Beamer slide will come in a box. In some theme, it will come in a box.
Yeah, no, you will just see subtitle will come like this.
Okay. In the title page, it will appear.
Oh, okay. So sorry, you asked about the title page, right? Sorry. Yeah. So there is a title, and I think there is a subtitle here. I'm not 100% sure about it. Let me just check. Yeah, subtitle will also come there.
Okay, we cannot. Okay, out of the box, we cannot keep it, right?
No. See, the thing is, you can do it definitely, but you just have to define it as something else.
Okay.
So
fine.
this is a feature of this particular theme that it is appearing inside the box.
Okay, right.
Okay, you can define it. You can define it as a bold or particular font, particular size, everything you can define and put it in the place that you want.
Okay, right.
So like all these things are entirely customizable. So according to your need, you can do it. There is no restrictions as such. So usually it is done in this way so that you don't have to think about it. Okay?
Right.
It will be uniform. You don't have to think about what should be the location, what should be the font size and shape and everything. You don't have to. If you say subtitle, it will take care of it. So that is the idea.
Right, because like while I'm preparing some presentation, like I want to type where I'm giving that presentation. For example, now it's Curry Leaf Day 2020. 2022. So it won't be look good if it is inside the box, because in the box it will be the title of the presentation.
It will be the title. Okay. So if you want, you can actually type something and actually specify the location also. That is also possible.
Okay. Thank you.
Yeah.
Okay, thanks, Kiran. It was a wonderful session.
Oh,
I
yeah,
hope,
thank you.
many people who already knew how to create presentations using LaTeX also have got many things out of your presentation. So, thanks to Kiran, thank you all the participants. So, I would just like to mention that after this session, today evening, we are going to have virtual student seminar program. We will be live streaming these presentations by MTTS students, participants of this year's MTTS on the Curry YouTube channel. So today we have two presentations, one by Prapti from St. Xavier's College. The topic is dimension formula for the sum of subspaces, and the other by Milak Kumar from IISER Behrampur. This topic is Rolle's theorem using proof of Rolle's theorem using nested interval theorem. So that is about the VSSP. And tomorrow we are going to have our first session at 2 p.m. by Professor Brindavan Sahu. So hope to see all of you there. Thanks a lot. Thank you, Kiran.
Yeah, thank you. It was a nice session. Yeah, thank you, Omkar, for organizing this, and I thank Meghna for suggesting my name to you. Like we had conducted a workshop, so she suggested my name. So from there, this started. So big thanks to you, all of you.
One thing, can you share the slides and the code?
Yes, definitely. So I will share the entire folder, so you can refer to it. So like whatever we have discussed,
Okay.
everything will be there. No problem.
Okay,
Yeah.
we will share to the group or to the mail.
Yeah, we will try to share the files in the group.
Okay, fine.
Okay. Yeah. We'll discuss with Kiran and let you know on the WhatsApp group.
Okay.
Okay, definitely, sure.
So it's going to be just one zip file. Okay, you can just extract it and
Okay,
start.
no problem.
compiling
We
this.
can extract.
Yeah. Yeah. Okay then.
Okay.
Yeah. Thank you. Thank you, everybody. Thank you for the patience. Bye.
Bye. So we end the meeting and also the live stream now.
Yeah.